Is the screen visible?
Yes, sir.
Yeah. Now, what about unit test 1 and unit test 2? It has to be completed before 5th of February. I'll be providing question bank. So, how do you want me to conduct?
सर हाउ डू मतलब
मतलब when?
देन हाँ सर वो नेक्स्ट वीक
How
में
do
ही
you
अभी
matlab
सर
it will be the question paper will be uploaded on the classroom in the like suppose suppose now I give you example like suppose on Saturday suppose if we are keeping at 10 o'clock, okay, so 9:55 I will upload the paper in the classroom, and I think 15 minutes extra is given for scanning and uploading the paper. So the time limit will be 10 to 11. That means 11:15 you have to upload the paper. Like that it will be. You have to scan and upload. So now you have to give me the date and time. And 3 days are sufficient for preparation according to me, because since I will be giving question bank and from that question bank itself the questions will be asked. Yes, tell me what happened. Hello, what happened? Hello, I'm not audible.
यस सर यू ऑडिबल
So what about date?
सर नाउ ऑन 25th Wasim sir has kept the UT.
Huh,
Uh,
25th. So can we keep it
sir,
on Saturday? Today
which
is
sir, which
20,
Saturday?
22nd. This
This Saturday.
22nd. This, and then in the month of February, 2nd February or 3rd February, we'll keep it UT2. Is that okay?
सर नेक्स्ट सैटरडे को रखते हैं ना
Next Saturday, then UT1 and UT2, it will be very close then. See now, next Saturday will be 29. I have no problem. Okay, then immediately you'll have to give 29. I can stretch only till 4th because 5th is the deadline, and usually I don't keep till last date. So if you're fine with that, I have absolutely no problem.
Sir, can you keep on 26?
That's what you have to give me date. So 26 and UT2. 26 is what day?
वेडनेसडे सर
Wednesday. Okay. And time
Sir, Wasim sir has given us 7 to 8 p.m. in the evening.
7 to 8 p.m. अच्छा.
सर लेकिन सर 26 को सर छुट्टी है सर तो 26 को आप सुबह भी मतलब दोपहर को रखेंगे ना तो हो जाएगा
26 को.
हाँ सर ये है ना
No, either see what you do. No, either you keep early in the morning, or you keep late in the evening. If you are keeping middle, no, okay, entire day is block. 26 का Republic Day, holiday रहते हैं. So you are once you give in the morning, then you are
अर्ली
also
मॉर्निंग ले लो
you are
ना
free.
शाम
Early,
शाम तक
uh, early morning 8 to 9. Is it okay? 8 a.m. to 9 a.m. So that you are also free, I am also free for the whole day since it is holiday.
Okay, okay,
Hmm?
okay, sir.
And what? So 26 Republic Day. Okay. And what about unit test 2?
सर 2-3 फेब को रख दो ना हो जाएगा
3rd February is what day?
Thursday.
Thursday. So but you will have lectures, no? In the morning.
हाँ
So
सर शाम को रखेंगे तो चलेगा ना वो
Thursday also 8 to 9. Is it okay? No, no, no. That won't be
सर
possible because I will be
सुबह
traveling.
सुबह नहीं सर सर शाम को रखो ना आप 7-8 बजे
शाम को. अच्छा.
हाँ
7-8 बजे थर्सडे. फिर 8 बजे रखना पड़ेगा. 8 to 9.
चलेगा सर फिर
8
शाम
to
को
9 या 9 to 10 ऐसा. Is that okay? Hello.
Yes, sir.
Yes,
Yes.
sir.
Huh? So we are freezing the date 26th Republic Day, that is morning 8 a.m. to 9 a.m. Right?
Yes, sir.
And then next is 3rd February, that is Thursday, that is 8 p.m. to 9 p.m. ठीक है.
सर आप क्वेश्चन बैंक्स कब दे रहे हो सर?
क्वेश्चन बैंक में आज देता हूँ. हाँ ये
ओके सर.
ड्यूटी 1 का. ठीक है.
सर तो 26 को रहेगा और एक 3rd को रहेगा ना?
हाँ, एक 3rd February Thursday from 8 p.m. to 9 p.m. that is in the night, and 26th one, that is Wednesday, that is 8 a.m. to 9 a.m. Is that fine? 8 a.m. morning.
Yes, sir.
Okay, ठीक है. I'll put this schedule on the classroom also. ठीक है, so that there is no confusion. All right, huh? So we will start with this uh, unconventional machining. Last time we discussed I'll upload it right away. So 3rd is Thursday, no? That is right, no?
Yes, sir. Yes, sir.
UP1 on 26th 1 2022 8 a.m. to 9. And you will have 15 minutes to upload. And you have UT2 on 3rd 2022 8 p.m. 9 p.m. Yeah, I have posted. Okay, so these are the components which are produced on EDM, and EDM we will be discussing separately because that is important. EDM tools, etc. So otherwise it will be repetition. So I'll conduct it separately. Now another non-conventional machining is your laser cutting, and I told you what is laser cutting is and what are the applications of laser. Basically in medicines, it is popularly used in medicines. It is used popularly for cataract operation as well as for kidney stone. So you have a laser source here. Just a minute. You have a laser source, laser beam, and the property of the laser beam is that it is directed in straight straight direction. That is, it doesn't get scattered. It doesn't get scattered. Everybody is joining. So this is a schematic diagram. If it is asked, you can reproduce this diagram. Laser beam machining device. as of laser sources are imported. So if you can start manufacturing laser source indigenously, then you can become millionaire, because as of there is no facility to manufacture laser source in India. So they are procured, mostly they are imported from China only. And you have a laser source here. This is a reflective end, and this is a lens which is used for converging the source to the workpiece. So the full form of laser is light emission by stimulated emission of radiation. That is, you have radiations. You know, you have studied this in engineering physics. The photons are emitted. That is from a light source, and they are made to fall. That is when the quantum of energy, that is when a light is made to fall on ruby crystal. So the atoms get excited, and in the excited state they are always unstable. So unstable means they will jump from one level, that is from one shade to another shade, and during this jumping the energy or the emissions will be produced, and that is nothing but laser. So this is what the principle is. This you have learned in no, this has been taught in 12th, and those who are not done 12th in engineering physics, that is same too, it is covered up. So this is a photon emission model, that is uh, incident energy. Okay, when it is impinged on the atom, that is nucleus, the electrons, they jump, they get excited, they jump from one orbit or from one shell to the another shell, and uh, during this you get the emissions in the form of the photons, in the form of matter, and like that there are millions and millions of electrons which are jumping in their unstable state, that is meta state, and you get a emission. This is a machine, a typical laser cutting machine will look like. So imagine laser beam machining like your milling machine. So here also you have X, Y and Z, that is you will have three axes X, Y, Z. But in case of milling machine, imagine vertical milling machine, the spindle in which the cutter is mounted, that is rotating, and here instead of spindle there is a laser source. Instead of spindle there is a laser source, right? And it can be used for cutting any material. You get very clean cuts, and the medium under which laser beam machining can be done is your air, then your oxygen, or sometimes nitrogen also. Usually nitrogen gives very clean cut, but it is little expensive. So these are the laser apparatus, that is we have a pair of mirrors for the reflection, then obviously you will have source of energy and optical amplifier, that is ruby rod or gas filled tube. The material removal rate is all in all these unconventional machining. Material removal rate is always low. When we say EDM में material removal rate is more, we are saying comparative. In comparison to other unconventional machining process, EDM is the fastest. EDM is the fastest. But if you compare with conventional, it is far less. Material removal rate is far less as compared to conventional machine. Like a milling machine may, suppose if you want to cut a pocket of say 100 by 100 by 50 mm deep, that pocket can be cut 100 by 100 by 50 mm. That can be cut in 1 hour. Whereas in EDM, it will take at least uh, around 10 to 12 hours in EDM, because you are directly sinking in solid. But that's why generally we don't do in solid. First we do roughing by conventional milling, then it is sent for heat treatment, and then followed by your EDM. Accuracy what you get is around plus minus 0.1 mm. You can do even machining, you can machine even small holes up to 5 microns. Only it depends upon the electrode. Okay, you should have that electrode, 5 micron diameter ka electrode. So limitations are electrode. Technology wise there is no issue, current or voltage, but that laser, electrode here means laser. That laser you should be able to produce of 5 micron size or 5 micron diameter. So this 5 micron holes or 10 micron holes is not possible in EDM. EDM minimum what we can go is around 0.3. 0.3. 0.3 is also very thin. So preferably or practically we don't cut holes less than 1 mm or 1.5 mm. Above 1.5 mm it can be sink or it can be cut on EDM very easily. Then we have electron beam machining. These are all sophisticated machining processes, electron beam machining. So that you will see in TIFR, that is Tata Institute of Fundamental Research. Then you will see in BRC, Baba Atomic Research Center, that is Anushakti Nagar. Some of the IITs also they have this setup. So in which, remember, it is done in vacuum. It is done in vacuum, whereas laser beam can be done in. It is not done in vacuum basically. It can be done in air, oxygen, or nitrogen. Whereas EBM is done in vacuum. There is no. You have to avoid the oxidation, right? And basically, it is nothing but because of the speed of the electron. So first is principally you have to emit. You should have something which will emit the electrons. You should have something which will emit the electrons, and that electrons are directed towards the workpiece. And there are deflectors, so deflectors, as I told you, in CRT, that is cathode ray tube, the electrons are moved so that you get an image. In CRT, electrons are made to fall on phosphorus coated fluorescent screen so that you get a image, a bright spot. Now here it is not phosphorus coated fluorescent screen, here it is workpiece. An electron, when it travels with very high speed, it will erode the workpiece. This is the principle. And there is a vacuum pump in order to create a vacuum. This cutting, electron beam machining, is done under vacuum. MCQ question, 2 marks MCQ questions. Like we saw in laser, we can machine hole up to 5 microns. In electron beam machining, it is up to 30 microns. But you get very superb surface finish here. 0.4 to 0.6 microns super finish is possible. Again, it is done for micro machining like laser beam machining, slotting, scribing, engraving, turbine blades, which are very hard and which are made up of alloy steel. So that can be done with electron beam machining. Then see, we have just seen laser beam machining, that is LBM. Then we have seen EBM, that is electron beam machining. So you have a diagram also for that. And next is plasma arc machining. Again, not important from examination point of view. Examination point of view, the EDM, Viridium, and your laser beam machining. Three are important. Here, plasma arc machining mein, plasma is the fourth state of the matter. So, plasma is used for cutting or for eroding the material. So, you have a setup here. Then you have electrode, the plasma gas, and the plasma is created, that is argon, gases like argon, they are ionized. So you have to develop an arc, then the gas will get dissociated and which will produce the temperature very high, it will produce, and that will create an arc, and this arc is struck across your cathode, and that will erode, this arc will erode the workpiece material, and because of the high temperature, the nozzles, this nozzle, this has to be cooled. So there has to be an arrangement of water cooling of the nozzle. So here the speed, that is cutting speed, is 250 to 1700 millimeter per minute. So plasma machining is bit faster because of the higher temperatures. But again, see, if material removal rate is more, then you have to compromise on your surface finish and your tolerance. If material removal is less, then you can get good finish as well as you can get good tolerance also. So in plasma arc, you get accuracy of say 1.5 and 0.8 mm. So that's why this plasma arc machining or palm is limited to roughing work only. Generally we do roughing work because we are talking about tolerances of 20 microns, 30 microns, that is 0.02, 0.01. So this is nowhere closer. So it is generally used for roughing. So profile cutting in SS, that is stainless steel, aluminum alloys, then hard and difficult to machine material. So those are most commonly done in plasma arc machining. Then you have ion beam machining. So laser beam LBM, that is laser beam machining. Then EBM, that is electron beam machining. Then PALM, that is plasma arc machining. Then IBM. IBM is name of the company also, but here IBM is your ion beam machining. So here it's like a sandblasting. In sandblasting, what we do, the sand or the steel balls, sandblasting or shot blasting. इसमें क्या होता है, sand or steel balls, they are made to impinge the workpiece, the rough surface of the workpiece, and under the higher speeds, the steel balls, they strike the workpiece surface with high speed and the scales are removed. The oxidized surfaces are made clean. So if you further increase the speed of these balls, then what will happen? It will erode the workpiece material. That means what? Some kind of a erosion or some kind of a machining will happen. So instead of balls in ion beam machining, we are using ions. So we have to produce the ions, and then ions, they are accelerated with the help of the electron gun, and then they are directed. Then they are directed. So of course all this machine, majority of this machine, plasma bolo, electron beam, laser beam, ion beam machining, they are all CNC machine, computerized numerical control, because if you want to cut a particular profile, then you need to move that beam as per the profile. So X and Y, at least it has to be a 2-axis CNC machine. This 2-axis CNC machine. These are some applications, that is micro machining, then shaping of optical parts, then machining of wire dies. Then you have chemical machining. So chemical machining is nothing but your chemical is used. As I told, principally what happens if you keep your workpiece in a chemical, if you keep a workpiece in a chemical, then after few hours you can see that the surface is surface get eroded or surface get itched. So same principle here, chemical machining mein. So wherever you want to erode the material or wherever you want machining not to happen, so those surfaces are covered and we say masking the surface which is not to be machined, which is not required to be machined. That is what is called as the masking. That process is called the masking. And there are some special material which are used for masking, because your acid, it should not attack that surface. So wherever it is not covered or uncovered portion will only get attacked by the acid and will be itched away. So usually what happens, the chemical machining, the material removal rates are less because you are dipping it inside the acid and waiting for erosion of the parent or the base material. But if you want to control material removal rate or if you want to make it fast, then we pass electric current, and that is what is called as the electrochemical machining. Electrochemical machining. Again, chemical machining is also popular because the running cost is less. Running cost is less because there is no electricity involved. There is no electricity involved. So that's why your chemical machining is preferred. Otherwise, there is no other advantage as such of the chemical machining. These are the applications. Alden Rodriguez, you are joining very late. Then you have photochemical machining, or it is also called as the photochemical etching. Photochemical etching. So this is again a 5 to 6 step procedure where the components are subjected to ultraviolet light, and again the surface to be etched is unprotected, and surface which are not to be itched, they are protected. And there is a kind of a film, which needs to be developed. Photochemical machining is useful for making very thin components, machining thin components, where the component or the workpiece will not withstand the tool forces. Like suppose you must have seen in printed circuit boards, you must have seen the ICs. Okay, so that IC chips machining, so it will not withstand the cutting forces. So in that case, we go for photochemical machining or even electrochemical machining. That is this. So electrochemical machining it works on the principle of electroplating. Only it is reverse of electroplating. In electroplating, the material is deposited. In electroplating, material is deposited, whereas in electrochemical machining, the material is removed from the workpiece. Material is removed from the workpiece. Then in electroplating, workpiece is positive, whereas in ECM, the workpiece is negative. Workpiece is negative. So the electrons which are ejected out from the tool, they carry, everybody knows, electrons carries negative charge and the workpiece is positive. So the electrons which are coming out from the tool, which is cathode, they are attracted towards the workpiece, and the speed of the electron is also high. So those electrons, it's something like your electron beam machining. Only the difference is here the shape of the tool is contoured. So whatever shape you desire or you want, okay, so that shape has to be given to the tool. So the electrons are coming out of all the surfaces and they impinge on the workpiece material, and your erosion in the workpiece happens. So principle of electrolysis is used here, and you have to remember the polarities again for the MCQ point of view. Like in electrochemical machining, the workpiece material is anode or positive and tool or electrode is cathode, that is negative. Electron carries negative charge and they are attracted towards the workpiece. These are the parameters: material removal rate, tolerances, surface finish, overcut and taper. Overcut matlab little more than the desired size. That is what is called as the overcut. And taper means you don't get a straight hole, you get a tapered hole. You get a tapered hole because of the secondary discharges, and that we will see in idiom. What do you mean by this overcut and taper? These are the applications, ECM applications. So machining of hard heat resisting alloys or cutting the dies. All these unconventional machining processes, the advantage is they are used for hard material, machining of the hard material, which is the limitation in conventional machining. In conventional machining, it is very difficult to cut the hard material, and that's why we go for unconventional machining. Any unconventional machining you talk about or you consider, it will cut the hard material. Now same is the electrochemical grinding. Now our normal grinding may there is no electricity. I mean there is no electric current which is passed between your grinding wheel and workpiece. So electrochemical grinding is exactly same like your electrochemical machining, only instead of tool, the grinding wheel is used. In unconventional machining, ultrasonic, that is EDM is first, then laser beam machining is second, then third is your ultrasonic machining. Water jet machining is also slowly becoming popular. Water jet machining, and you can see now setups of water jet machining rising up. But ultrasonic machining is also very popular. Ultrasonic machining. The basic application of ultrasonic machining is in cleaning, and that is what is called as the ultrasonic cleaning. The especially the semiconductor industries. Semiconductor industries, ultrasonic cleaning is very popular because these small chips or PCBs or diode resistance, they cannot be cleaned by normal or acid cleaning method, that is 7 tank process we called as it. It is not possible. So we go for ultrasonic machining or ultrasonic cleaning. So it is used for machining, it is used for cleaning, it is used for welding also, for bonding also. So the principle is this: you have a transducer which creates the vibrations. This is a tool head, and whatever shape you want in the workpiece, that shape is given to the tool. Like here you can see the tool, there are projections. So same projection will be cut in the workpiece. So you have a nozzle through which abrasive slurry will be coming continuously, and that abrasive slurry erodes the material. Slurry means it's a liquid kind of thing. So this tool vibrates, as well as this tool goes up and down also. So that the depth is achieved. Vibrations are in the range of 16 kilohertz and more. This transducer will convert the input electric energy to vibrational energy or mechanical energy. And basically transducer is nothing but a piezoelectric material, piezoelectric crystal. Abrasive slurry means grains like your aluminum oxide, silicon carbide, and plus liquid. Again, metal removal rates are not so attractive, but you get good accuracy, 5 microns. At the same time, it is not very slow also. Ultrasonic machining process is not very slow also. Normally, these laser beams machining or ultrasonic machinings, they are specified by the power source. Like say, people say I have laser of 2 kilowatt, that is 2000 watts. So people understand immediately what will be the size of the machine and what will be its machining rate. So hard materials like glass, ceramics, carbides, they can be machined easily by ultrasonic machining. Then this we already discussed: water jet, abrasive water jet. In water jet there is no abrasive, whereas in abrasive water jet the abrasive powder is used or grains. Now this is to summary the process capability of non-conventional machining process. So if you look at the material removal rate, conventional machining, this is conventional machining, MAC, conventional machining, it has material removal rate of 825 millimeter cube per second. Look, 825 millimeter cube per second. So as against your highest material removal rate you will get in plasma arc machine, that is 2700, which is higher than your conventional machining, but at the sacrifice of accuracy. You don't get accuracy, you get very poor finish as well as you get very bad accuracy also. Tolerances you don't get. So palm is followed by electrochemical machining. It has 550 millimeter cube per second. And then next is your EDM. And if you look at this EBM, LBM, AJM, the material removal rate is very low. Finish. See, plasma arc machining, rough. So at the first instance, we just ignore plasma arc machining unless your material removal rate is the criteria. It will cut like anything, plasma arc machining. And if you talk about surface finish, then you get a good surface finish in ECM and ultrasonic. And rest of the unconventional processes, the finish is almost same, 0.4. Accuracy. See, there is a difference between surface finish and accuracy. Accuracy matlab tolerance. Like suppose I want a size of say 100 dia. So accuracy means whether I am getting 99.99 or whether I am getting 100.01 or whether I am getting 100.5. That is what is called the accuracy. And surface finish means that is the distance between the height, that is distance between the peak and the valley. That is surface finish. Smoothness. So in grinding you get a very good surface finish. In lapping again still better. Then power consumption. So laser beam machining mein power consumption is very high. And that's why per hour rate of laser beam machinings are high. They are as high as around 7,000 rupees per hour. And then penetration, that is what is the depth, that is how fast the tool or the electrode is penetrating the workpiece. That is what is called as the penetration rate, millimeter per minute. So that's again fantastic in palm, that is 250 millimeter per minute. So that was about your unconventional machining. Now let's go for EDM. So before that, let me see whether I have missed anything. Conventional, non-traditional, non-conventional definitions. It's fine. Mechanical, electrochemical, chemical. These are the mechanical processes. You have chemical processes, electrochemical, electrothermal. Advantages. This EDM, this is a setup for your electron beam machining. Okay, this also we have seen. Electron beam machining ka setup. Plasma arc machining also we have seen. Plasma arc machining. How the arc is stuck. Laser beam machining. This is your laser source. Usually it is neo NEOY, it's a neodymium. PCM also we have seen. This is how the material removal rate is calculated. Then chemical machining. This is your ultrasonic machining. So tool is vibrating. Abrasive jet machining. With the help of the abrasive or grains, the machining is done. Then water jet machining. An abrasive water jet, that is your abrasive grain plus water, AWJM. Now we'll go for EDM, that is because this weightage is 10 marks, either EDM or wire EDM. Okay, so I'll show you the setup. So this is the setup of EDM. So here the workpiece is submerged in a tank, and the tank has a liquid which is called as the dielectric. That liquid is called as the dielectric. Now what you have to remember here, that this dielectric is pure water or kerosene. The very first thing is that EDM is used for cutting the hard material, which cannot be cut by conventional machining processes. That is the first thing you have to remember. Then you can say whether it is limitation or disadvantage of the EDM. It can be used only for electrically conductive material. That is, your workpiece should conduct the electric current. Electro discharge machining, it is also called as the die sinking machining. There are various names. It is also called as the spark machining, spark eroding, burning, or wire erosion. Different names. How the material is removed? Because of the sparks which are coming out of the electrodes from all its sides. That is, spark will come from here, here, and then from the bottom also, from all the sides. The spark will come, and that spark is generated because of the voltage, higher voltage in the range of 10,000 volt or so. So in the spark, what happens? The electron jumps and they travel toward the workpiece with high speed. Then shape of the cavity which is cut in the workpiece conforms to the shape of the electrode. So there is whatever shape you want in the workpiece, the electrode has to be of the same shape. And this distance or the gap between the workpiece and electrode is called as the spark gap. So that is called as the spark gap. And this spark gap can be, it varies from 0.05, that is 50 micron, to 0.3, that is 300 microns. More the spark gap, I mean if the current is more, the spark gap is more, material removal rate is more. If the current is less, the spark gap is less and material removal rate is less. Less material removal rate, that means surface finish is good. Good surface finish. Again, your electrode is connected to negative, that is cathode, and workpiece is positive. That is, again, this is reverse of electroplating. In electroplating, the material is deposited, here the material is removed. And we want material to be removed from workpiece. So if we change the polarity, like now here it is negative, electrons will move from here and they will get attracted towards positive. So workpiece will erode. Now if you change the polarity, like if you make this workpiece as negative and electrode as positive, so the erosion will occur at electrode. So your electrode will wear out. Now you have to remember that electrode is negative and this is positive. You have to remember that there are electrons that is carrying negative charge, they move towards the workpiece. Similarly, you have ions also which are coming out of the workpiece carrying positive charge, and they get attracted to the electrode which is negative. So the erosion will also occur at electrode, and that is what is called as the electrode wear. So the erosion will occur both. But then why we are giving negative to the electrode? Because we want more erosion at the workpiece and less erosion to the electrode. There are some machines, the technology. See, these electrical circuits are nothing but RLC, that is resistance, inductance and capacitive, RLC. So the technology is built up in such a way that is called as the nowhere system. Nowhere system. So in nowhere system, what happens? The electrode wear is very less. Electrode wear is very less in nowhere system. Or we can say zero wear system. This is a rectifier which is used for converting your AC to DC. This current control device, it is used for controlling the current or voltage. So you get different, you can use or you can select different current or different voltage. Then you have something called as the servo control. What happens? There should not be any shorting between the electrode and workpiece. Shorting means your electrode should not touch the workpiece. There has to be a small gap. If the electrode touches the workpiece, that means what? It is like a shorting, that is positive and negative. They are touching each other. So that should not happen. There has to be a small gap, 2 micron, 3 micron. Just enough for electrons to jump or for the spark to occur. Okay. At the same time, you have to move up the electrode so that the material which is being cut has to flushed away, which has to be discharged away. So for that, you have servo control, so which keeps on moving this electrode up and down, up and down. And that is also called the pulse on and pulse off time. So that we'll see, pulse on and pulse off time. So when the electrode is taken up, that time, because of this dielectric which is being flushed, the cut material is flushed away from here, and then again it comes down and it tries to kiss the workpiece, and during that the erosion happens. Again it moves up. So this is what is called the servo control. So the purpose of servo control is to control the movement of the electrode precisely up and down. Barabar. So, and the electrodes are heavy. So remember that electrode has to be moved up and down. Electrode heavy matlab depending upon the workpiece. If the workpiece size is big, then electrodes will be heavy. So that heavy 5 kilo ka electrode you have to move up, down, up, down. Up, down means what? The braking action also has to be precise and powerful. It has to stop at that particular distance. Okay, so this is what the principle is. Material is removed from the workpiece by a series of rapidly recurring current discharges. And as the gap reduces between the workpiece and the electrode, the spark jumps, electron jumps, and the erosion occurs. So once the current flow stops, so there is a voltage on, voltage off. There is current on, current off. So once the current flow stops, there will be new liquid dielectric. Dielectric matlab it's a kind of a liquid in which your workpiece is submerged. Okay, so when the current stops, the dielectric is usually conveyed. So in order that spark should jump, so the dielectric which is insulator, so for a moment it acts as a conductor which allows spark, which allows some kind of a shorting, but it is only for a milliseconds. And again it moves up, electron moves up. Okay, try to understand. So the dielectric is broken, that dielectric which is insulator is broken for a time so that the shorting occurs and the material removal takes place. So the purpose of dielectric is to pass the current or voltage between the electrode and the workpiece. This is the principle of TDM. Hmm? But the shorting should not be continuous. It has to be very for a few milliseconds. So I will show you the pulse. So the pulse is like this: pulse on and pulse off. This on time, off time. So in on time, your machining will happen. So electrode is touching for a moment, and in off time, electrode is retracted up. Electrode moves up. So no machining. Like that it is. Okay. So we'll stop here. I'll quickly take the. I think this Eldrin and Channel, they have joined late. Channel has joined just at 10 o'clock. Channel, isn't it? Yeah. Ronak, Barbos,
Present, sir.
Alerao.
Hello, sir. Shaunak present, sir.
Okay.
Present, sir.
Barbos is
Monish present,
absent.
sir.
Oh, sir, Owen is present, sir.
Vedant,
Present, sir.
Danish,
Present, sir.
Sheldon DeMelo.
Present, sir.
You joined late.
No, sir.
Elroy,
Present, sir.
Tyson.
Present, sir. Sheldon.
Yeah, you joined late, no?
No, sir.
No?
No.
Safe?
Present, sir.
Nancy,
Present, sir.
Om,
Present, sir.
Sheldon Lopez,
Present, sir.
Kenan,
Present, sir.
Leela, Samiksha,
Present, sir.
Dhruvi,
Present, sir.
Aldrin and Channel, you joined late. What shall I
Sir,
do
I
now?
joined at 9:15.
Aldrin,
Yes,
Channel,
sir.
you joined at 10 o'clock.
No, sir, I was joined, but my network was gone. That's why I was left.
Okay. Duma, Trivedi,
Sir, present.
Archie.
Present, sir.
Okay. ठीक है, thank you.